Hello everyone, how are you doing? Another video of the Lean Six Sigma workshop. This is your guide, Dr. Mahmoud Al-Odeh, and in this video we'll be talking about the control phase. In the previous video we talked about the cost benefit for implementation. What's the cost and benefit for each solutions? If we need to implement several solutions, in order to pick one of them, we have to look into different criteria. One of them is the cost benefit, return on investment, selection of solutions based on the different things, based on the prototype and pilot studies. We talked about uh, the design of experiment and all these things. We have to test it. We have to try it at the small scales. We have to test the solution on a small scale so we could implement it at a larger scale and get the benefit. For the control phase, we will be taking the input from the previous phase, which is the implementation phase, and bring it, use the tools, and have an output as you see in this chart in front of you. So the input, we will have cost benefit for different solutions, selections of solutions based on different factors, whatever tools you use, and we have to have an implementation plan. For the tools that we're going to use in this control phase, we're going to use the control plan. We have to have a plan how we could control and sustain the results for the future. We need to look into the statistical process control. We have to develop some charts, process control charts. We have to implement some lean tools such as the 5S, the visual management, Kaizen, Kanban, total productive maintenance, etc. We will talk about all these tools in this video. And as output, we will have implemented solution, completed implemented solution. We will have a revised system. We have to have control plans for to sustain the benefits into the future, improve process capability, and it's really important to, by the end of this phase, you have some documentation of lessons learned, what you've learned, what's your success in the whole project, what's your failure. So, and not only to document it, also to share it with the whole company, so you other Lean Six Sigma teams will benefit as well from your experience and from your project. The first thing that we're going to talk about the control plan. In order to, after implementing the solution, you have to measure, you have to observe the process, because you need to collect some data. And based on the data, you will see if there is an improvement happen to the process or not. There's these the data collections, we've talked about it in the measure phase, so you could go back and review them, such as the check sheet, the Pareto diagram, the histogram, etc. And also in this phase, once we collect the data, we need to find out if what the process level, the new, because we have a new process right now. Once we have a new process, we need to find out, did we improve this process? So we need to find out, did we improve the capability of the process? Did we change the sigma level? Did we improve the efficiency of this? Did we reduce the variation in the process? And these all will result into high quality products or services. So again, DPMO, one of the measures that you need to calculate and see if the new process has a better rate, lower failures, and a higher efficiency for the new process. Okay, let's talk about the control plan. The control plan created during the control phase of the Six Sigma project. The control plan is a systematic methodology to develop a data collection strategy for the process. Okay, so now you have to have the control plan. Okay, what do you need in order to control the implementation solution, the implemented solution? You have to have some tools. Okay, uh, this plan will contain information about product, the process characteristic. It also states the control methods to be used, data to be collected, and steps to be taken if problem detected. So these are really important. So what we're looking for, control methods, what techniques you will be using to control the implemented solution, data to be collected, and steps. And number three, steps to be taken if there is any problem, if there is something happen and you haven't control. You have to have some risk planning, and avoid any risk happen. So you have to have a plan for if you've seen any risk like this, or if you see an unexpected result by implementing the solution. Why this is important? Why should I create control plan. There are a lot of benefits of developing a control plan. One is systematically recorded data from the process to proactively determine that the process is under control. So one is, as I mentioned here, we need to see if the process is in control or out of control, and what we need this plan to follow some steps, and these steps will help us to decide if the process in control or out of control. Use preventive maintenance to reduce the errors by determining the errors as soon as they occur. So one of the benefits is to determine if the errors, and if there's any error happen, we have to take care of it as soon as possible. And this is what we call preventive maintenance. Preventive maintenance is having a plan to maintain any issues, to solve any errors, and develop a solution for that. Number three, you need to get a buy-in from all team members who can see the result of the process and suggest continuous improvement in the process. Okay. Sometimes when we work in a company with the teams, it's really hard to find uh, a buy-in, which means you can't find an agreement from your team or support from your team to implement solutions like this. But once they see the result and the benefits of implementing the Lean Six Sigma methodology and seeing the improvement in the process, they will agree to implement. So it is really important to convince the people that this is a very effective tool, that you need to implement it. Number four, provide input on the critical to quality parameters which have maximum impact on meeting customer requirements. So the control plan, as I mentioned, it's a way to control and maintain the benefit that you gain from the Six Sigma project. And once you focus on the critical to quality, these are the characteristic that would impact the quality of service or quality of products, and also these will impact the satisfaction of a customer. So these are really important. We'll give you more information. You will get closer to these inputs, to these parameters, and you will be able to control them. All right, how we could create a control plan. In order to create a plan, you have to have you have to have a template, which you could use any template. You know, there are so many templates provided by American Society for Quality, or you create your own template to show them the step by step on how we could maintain this. So in this template or this document, you have to have three sections in them. Three sections. One is for the for administrative. It states who created the control plan, contact person for questions, name of person who is asking the measurement. And section number two, process section. Describe the process and its characteristic, which would be measured through the control charts. So number one is the administrative section, which include the person who's asking, who created the control plan, the person who's taking the measurement, and contact information if they have any questions. Number two, as I mentioned, the process section, including information about the process, characteristic, anything that will help us to document or collect the data. Number three, section number three, control methods section, describe the data that should be collected. What kind of data? So as you see, there are a lot of data you can collect from a process, but you need to focus on a specific data. And I believe you have to focus on 3 to 5. Don't go more than 3 to 5. 3 to 5 depends on the critical to quality. These are some of the parameters, some of the measurement that you could use. Make sure these are you can measure it, measurable concepts or measurable techniques. This includes information like measurement type, sample size, levels of verification and frequency. It also has information on the desired behavior and corrective action to be taken if the process goes out of control. So these are the three sections that you have to have. It's basically telling you who's responsible for this control plan, who's going to get the measurement, what is the process that we need to collect, include more information, and number for what exactly we're looking for to collect. So now these are the three sections of the control plan. Control plan must quantify, as I mentioned, should be measurable. You have to look into parameters that you can measure, and these what we call the maybe one of the measurement cost of poor quality. You have to have the cost of poor quality associated with the failure to detect. If there is a failure to detect any errors, show them, show the administrative, show the company CEO is if we failed in finding this error, this is how much will cost us. So this is where the cost of poor quality will take place. In the control plan, we mainly focus on, there are a lot of tools that you could use, measurement tools, but mainly focusing on the control charts. And this is a really powerful tool to detect any errors that may impact the behavior of the process. So what is the control charts? It's a chart that we use it to study the behavior of the process. We look into the process and we say, okay, is a process in control or it's out of control? And what we're looking for, we're looking into the range for the data. These are some, this is a type of control chart. You'll see that there is a mean. This is number one, the information that we're looking for. Can highlight it here. This is the mean, the mid size in the middle, the average of the readings. You have the upper control limits, you have the lower control limits. These are right here. This is identified and calculated. We talked about it. There is a video on how to create a control chart. Go back and review it. And there is specification limits and upper specification and lower specification limit. This is what we call the voice of the customer. The voice of the customer is the specification limits. You're asking the customer what is acceptable for you, and the control limits, it's the voice of the process. What's the process is capable of providing. And once you develop the control chart, you will see if there is any a process out of control, or if the process is in control or out of control. If there's something like this here on customer number 7, you will see that took them 20 minutes to take care of that customer. So there's something happened. This is a special cause variation. You go back and review the cameras or the log, or you start asking questions, or what exactly happened here, and why it took them a long time period for serving customer numbers. So it is very effective tool to find out if the process in control or out of control. Some of the concepts that we need to remind you about it to be able to create a control charts. The mean is a collection of numbers. Is their arithmetic average. So this is the average computing by adding all the numbers, dividing them by their numbers. Upper specification limits and lower specification limits. The upper and lower specification limits are determined by taking the voice of the customer. So again, this is based on the voice of the customer. The process would satisfy customer requirements if it falls within the specification limit. As long as your process are able to give you within these specification limits, the customer will be happy. Now there's a level of happiness for a customer that's beyond this workshop, but we could talk about it on a different course or a different topic. Upper control limit and lower control limit, these are defined by the Six Sigma expert and usually lie within the upper and lower specification limits. Most likely it's going to between these specification limits. These are calculated from process data, and if all the process data stayed within the control limits, then it is very likely that the variation is inherited in the process, such as common cause variation. So the control limits provide boundaries for process which is under control. So we're talking about the tolerances in a process. So we're going to boundaries or tolerances. It depends on if the process data lies outside the control, then it is a special cause variation and indicated that the process is out of control. This reminds me that we have to talk about special cause variation and a common cause variation. Assignable cause variation, it's outside influence, black noise, um, potential controllable, how the process is actually performing over time. This is the assignable. Common cause variation, this is from the nature of the process. Variation present in every process. So no matter what, even if you have a Six Sigma process, you still have some uh, variation in the process. This is not controllable. If you need to control it, and you have to redesign the whole process. But the assignable, it's the special cause variation, or we call the assignable. This is something that a special cause or special factor that impacted the process. You have to investigate, you have to look, you have to use the fishbone diagram, you have to use a different tools, the Pareto chart diagram, in order to find the root cause of the problem. And once you reach the root cause of the problem, you solve, you remove this. And this is the goal of any quality team, any Lean Six Sigma team, is to reduce the variation, reduce the waste by reaching to the root cause of a variation. Uh, More concept that I don't want to skip. The out of control process is said to be out of control if there is a process data that lies above the control limits or below the lower control limits. The diagram, we see one point, like the diagram that I just showed you, you see one point above the upper control limit, which indicates that this is a special cause variation, hence the process is out of control. Also, we look into another way to look into if the process is out of control or not by looking into the rule of seven. If there are seven consecutive data points either above the mean or below the mean, then that may be indication that the process is shifting. So if you have seven points that above the average or below the average, and this could be indicating that there will be a shift in the process. Please note, once it's detected that the process is out of control, the project team can proactively try to determine the reason for the process getting out of control. Steps can be taken to bring the process back under control. So you could maybe recalibrate the machine, you could maybe give a training, you could maybe provide a faster technology, a faster computer or a faster machine that will help you to stay within the control limits. Now we're very much done with the control. So the whole idea of the control phase is to, once you implemented the new solution, you have to keep an eye on the new solution using a systematic technique. And this is what we call it the control plan. You have to have an exact plan. How would you control the new implemented solution? And one of the things that we need to talk about is the system reanalysis. This is we do it through the control phase. We need to, because we basically have a new system, a new process. Once you implemented a new solution, you have a new process. So we need to reanalyze the system. After doing statistical process control, we may need to do periodically reanalysis. So we say, okay, we're going to do reanalysis every once a month or twice a month or once a week. It depends on the need of that. At the end of the improve phase, the Six Sigma are completely implemented. We talked about that in that we have the improvement phase. After the improvement phase, we implement the solution, and now it's time in the control phase is to control the process. Then there is an analysis performed to ensure that the gains from the Six Sigma project. So now in the control phase, we need to ensure that we going to get some benefits. We have a better capability. We have a higher Sigma level for the process. The measurement system is analyzed and recalibrated if required to ensure that it continues to be accurate and can be provide appropriate information required for the statistical process control and other control activities. A control plan for sustaining benefits is created as was discussed earlier. So you need to maintain these benefits. You know, some teams they leave the project. They say we're done with a project and we improved it, but they have no future goals. How they could maintain and sustain uh, these benefits. Some of the things that we could use to sustain the benefits is using the lean techniques, which I'm going to talk about it in just a few minutes here. Lean techniques such as the visual management. Say, okay, instead of leaving the system after we improve the process, instead of leave it like this, how about if we create a visual management? We create some visual processes step by step showing how to use the machine, how we could highlight some areas with a yellow to for safety. How about if we go to the warehouse and we organize the material by using a green, yellow, red tags and based on the priority, how often we use it, and this is what we call the 5S strategy. So it is important to maintain. This is the whole thing. Is not just only control it before you leave, but also to have a future vision and a future plan in order to maintain it. And you need to help them. And the last thing that I want to talk about it here before we talk about lean, I'm going to leave lean tools into a separate video so you could learn better about the lean and the techniques that we could use it. But keep in mind that some of these lean techniques can be implemented in the control phase to control the process and maintain future gains, not and looking to even a future continuous improvement. We need to keep that in mind. We're not only here to implement a new solution and leave. We need to implement a new solution and ensure this solution will carry in the future, will be benefit the team, will benefit the company in the future. So this is what we need to ensure. We need to ensure that the solution is implemented, we gain benefit. Now, before we give it to the owner, before we give the process to the owner, we need to ensure that we maintain this, we sustain these benefits for the long term. So our goal is not just only for the short term, our goal is for the long term, such as how often we need to analyze and reanalyze the data, how often we need to collect the data. And you could teach them, you could teach the owner of the process on how to do this analysis. What kind of tools or lean tools that I can use? Can I use the 5S? Can I use the Kanban or Kaizen? Can I use uh, 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 visual management to, to, to maintain these improvements? Anyway, we're going to talk about lean in a separate video, but these are attached to the control phase. I thought that would be good to have it in a separate video because I want it to be in a separate video because I want you to view it on a separate on your own and a separate than this. The last thing in the control phase, you have to have lessons learned. As I mentioned, this is one of the output. It's Keep in mind that not all Six Sigma projects are successful. They might fail, but or they might not get the benefits as expected earlier. Therefore, you have to have some lessons learned. These lessons learned should be documented because you need to learn about that. You and your team, you need to learn from your failures. Also, you need to share your experience with other Lean Six Sigma, so that will help them to avoid any mistakes that you've been into it. Why this is important? Because it will help us as a company reduce the overall cost, increase efficiency, improve customer satisfaction, better moral, increase rate on investment from Six Sigma projects. We need to improve the ROI for these projects. I'm going to stop the video right here, but I'm going to meet you in another lean tools, and there are a lot of good information that I want you to focus on uh, how we could implement lean, what factors we're going to use, and etc. I'll see you in a different video. Bye.